Students, in this class we will study how to represent a complex number in polar coordinate form. Now suppose you are given a complex number, say z equal to x positive iy, then this complex number can be written of the form r times cos theta positive I times sin theta. Now r represents the magnitude and theta is the argument, okay, of the complex number. Now r has got a formula which is root of x squared positive y squared, and theta has got a formula tan inverse of y divided by x. So these are some of the important points that you have to know. This is the knowledge point number 1, this is point number 2, and point number 3. And of course it is easy to compute r, but with regard to the argument you need to be a little bit careful, because the value of theta should lie between negative pi and positive pi. Now suppose you are having an alpha, okay, say the required, or in this case if you are evaluating a complex number and you are finding some argument, say alpha, and if alpha is present somewhere in the first quadrant, okay, so this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now if alpha is present in the first quadrant for this complex number z, then you can take theta to be as alpha. So this will be the argument for this complex number z. So this is case 1. Now we will study case 2, students. In case 2, suppose you are given a complex number, say z, and the argument for this complex number, say z, is found in the second quadrant, and that is alpha. So in this case you cannot take the value of theta to be as alpha directly. So what you got to do, you got to do a small evaluation. In this case theta would be equal to pi minus alpha. So have that in mind. Now case number 3. Now if you are given a complex number, say z, and the argument for that particular complex number z is found in the third quadrant, in that case your theta should be equal to alpha minus pi. So this is case number 3. Now let us move on to case 4. Imagine you are given a complex number z and you are getting the argument for this complex number somewhere onto the fourth quadrant. In that case your theta should be equal to minus alpha. So we have seen the 4 cases. Have that in mind. So just for the sake of recap, case 1, theta is equal to alpha for the first quadrant. Now case 2, theta is equal to pi minus alpha when the argument of the complex number is in the second quadrant. Now case 3, theta is equal to alpha minus pi when the argument is found in the third quadrant for the given complex number. Now case 4, theta is equal to minus alpha when the argument for the complex number is found in the fourth quadrant. So in general, what are the steps you need to follow when finding argument? First and foremost thing, find out alpha. In this case it is going to be tan inverse of y divided by x. After finding alpha, find out in which of these cases that you can apply. After that, the final solution should be written in this form. Argument of the given complex number z is equal to arg, the argument of z, plus 2 in pi. So that should be the final answer for any n element of integers. So this is going to be your final conclusive answer for the given questions involving arguments of a complex number. Students, you should also know the properties that are connected with argument of a complex number. So these are some of the important properties you got to know. Now the first and foremost property is that argument of a product, say z1 times z2, is equal to argument of the first complex number added with the argument of the second complex numbers. Okay, so argument of the product is equal to sum of the arguments. So this is the first property. Now property number 2, argument, I can use the small a, argument of z1 divided by z2, the argument of the quotient is equal to argument of the first complex number minus the argument of the second complex number. Argument of the quotient is equal to difference in the arguments of the complex numbers. So property number 3 is also very vital and useful. Argument of z raised to the power n can be rewritten as n times argument of z. So these are 3 vital properties involving arguments and complex numbers. Any complex number can be rewritten of the form z to be equal to r times cos theta positive I times sin theta. Now this cos theta positive I times sin theta as a general form that you got to know, which is going to be cos of 2 n pi or pi n positive theta positive I times, I'm writing it down here, sine of 2 pi n positive theta, where n is an element of an integer. So this is a vital property that you have to know also.